Hello, we are on the topic of moment of inertia. Today we will discuss about how to calculate the moment of inertia of different section. How to calculate the moment of inertia of different section. Of different section. In this topic, we will calculate the moment of inertia of rectangular section, circular section and triangular section. Rectangular section. Let me draw a rectangular section. Let me draw a rectangular section of base B and depth of the rectangular section is D. We know CG of the rectangular section is center of the rectangular, CG. This distance is D by 2 and divided into two parts, equal to parts D by 2 and D by 2. Let us consider a small elementary area of dA. dA and let us depth of this elementary is dy and breadth of the elementary is equals to b. So area of this elementary is dA will be b into dy. The elementary area, small elementary area dA equals to b into dA. Now the moment of inertia of this small elementary area will be di is equals to, what is the moment of inertia? Moment of inertia is equals to area into perpendicular distance square. Say the perpendicular distance of the small elementary area is y. So the moment of inertia is equals to dA into perpendicular distance square. What is the dA? dA is equals to b into dy, b into dy into y square. If I simplify it, now it simplify b into y square to dy. This moment of inertia is the for small elementary area. Small elementary area, the moment of inertia of this small elementary area is di equals to b into y square into dy. Now the moment of inertia of whole rectangular section will be moment of inertia, total moment of inertia will be integration of di equals to integration of b into y square into dy. Put the value of the limit of this integration is, this is a CG. We find out the moment of inertia about CG. So minus limit will be minus d by 2 to d by 2. The moment of inertia about CG is equals to integrate it, be common. Integration of y square will be y cube divided by 3 minus d by 2 plus d by 2. Put a value of limit b into dq divided by 8 into 3 minus of plus dq divided by 8 into 3. It is equals to b into dq divided by 12. The moment of inertia of rectangular section about CG is equals to b into dq divided by 12, the most important formula to calculate the moment of inertia of rectangular section. Now second part is calculate the moment of inertia of circular section about CG. Circular section. Circular section. Let me draw a circle of diameter d. I have drawn a circle of diameter. This is the center of the circle, and diameter is and radius, relation of diameter and radius, d equals to 2r. Let me consider a small elementary area. Let me consider a strip, small strip. Let me consider a small strip at theta degree angle from the center. From the center means neutral axis or CG. From the CG, the small elementary from CG distance is say y, and the depth of the strip is dy, small dy. The length of this strip will be, we know the formula, 2r into cos theta. The width of the strip is equals to 2r cos theta, and area of strip is equals to 2r cos theta into depth of the strip dy. And y equals to, what is the value of y? Y equals to r sin theta. If I say, let me consider a triangle, equilateral triangle of theta degree angle, and this is 90 degree. So perpendicular will be sin theta, and base will be cos theta. So it is head to head is r cos theta, and head to head is r cos theta. So this is 2r cos theta, and this is r sin theta. So from neutral axis to CG of this strip is r sin theta. So if I differentiate it, dy equals to, differentiate with respect to theta will be dy equals to r cos theta into d theta. Differentiate with respect to theta. So dy equals to r cos theta into d theta. Now the moment of inertia of small elementary strip, small elementary area of the small elementary area will be the moment of inertia of elementary area, say delta I equals to, what is the moment of inertia? Area into perpendicular distance square. What is the area of the elementary? Area of the elementary is what? Area of the elementary is 2r cos theta into dy. So 2r cos theta into dy into perpendicular distance y, the whole square, y's whole square. So y equals to r sin theta whole square. So if I simplify it, 2 r square cos theta to dy equals to r dy, put the value of the dy equals to r cos theta d theta into r cos theta d theta into r sin theta whole square. Simplify it, 2 r to the power 4 sin square theta into cos square theta d theta. This is equals to r to the power 4 by 2 sin square 2 theta d theta. This is di equals to r to the power 4 divided by 2 sin square 2 theta. Formula of sin square 2 theta equals to 2 sin theta into cos theta. Sin square sin 2 theta equals to sin theta cos theta. Now integrate with respect to theta. Now integrate it with respect to theta. If I integrate it, r to the power 4 divided by 2 sin square 2 theta into d theta. This is the moment of inertia of this part. Now if I calculate the moment of inertia of whole part, then it's multiplying by 2. The value of the limit will be 0 to pi by 2. 0 to pi by 2. Integration, r is common, 2 and 2 cancel. Sin square 2 theta equals to what? Sin square 2 theta equals to 1 minus cos 4 theta divided by 2 into d theta. So r to the power 4 divided by 2, put the value of 0 to pi by 2 limit, put the value of the limit, integrate it, theta minus cos theta is equals to sin 4 theta divided by 4 and limit 0 to pi by 2. So r to the power 4 divided by 2. If I put the limit 0, value 0 is this 0, sin 0 is 0. The value of the putting the limit of 0 is 0 totally, and if I put the limit of pi by 2, this will be theta equals to pi by 2 minus sin pi by 2 is equals to pi by 2 is equals to sine 4 into pi by 2 divided by 4. Sine 2 pi equals to 0, so this value will be 0. So the value of the I equals to r to the power 4 divided by 2 into pi by 2. Now the moment of inertia I equals to pi r to the power 4 divided by 4, 2 into 2 4, pi into r to the power 4. Now if I put the value of r equals to in respect to diameter, r is the radius of the circle. If I calculate the moment of inertia in respect to diameter, r equals d equals to 2r. So here r equals to d by 2. Put the value of the r is in respect to r is d by 2. So pi into d by 2 to the power 4 divided by 4. The value will be pi d to the power 4 divided by 64. The value of the moment of inertia about Cg of circular section is I equals to pi into d to the power 4 divided by 64. This is the moment of inertia of circular section. Circular section is pi into d to the power 4 divided by 64, and the moment of inertia of rectangular section is about Cg is b into dq divided by 12. Now we have to calculate the moment of inertia of next triangular section. Triangular section. Triangular section. Let me draw a triangle. Let me draw a triangle. Triangle of base B and height of the triangle is say h. Now the CG of the triangle is h by 3. Height of the CG of the triangle is h by 3 from the base. This is the CG. Height of the CG from the base. Height of the CG from the base is h by 3. We know. Let us consider a small elementary of breadth say z and height of the elementary is dh and from top height of its height from the top is say h. Now consider an elementary area z. Consider elementary area, strip elementary area z into dh, breadth into height at a distance h from apex. This is the apex point. Apex is h of the strip of the elementary. So area of the elementary is area of an elementary is equals to z into dh. Now the moment of inertia of elementary about the base of the elementary is z. The moment of inertia of the elementary about base is di equals to area z into h, area into perpendicular distance h, minus perpendicular distance what, from neutral axis the perpendicular distance will be this distance, this distance will be h minus h. Total distance from apex, from base to apex is h, and distance from apex to elementary is h. So the distance from the CG to elementary is h by h minus capital H minus small h. So the distance perpendicular CG distance square h minus h is whole square. This is the moment of inertia of the small elementary strip, small elementary area. What is the value of z? How to calculate the value of z? This is a one triangle, say capital triangle is A, B, C, and a small triangle is A, D, E. So this is the these are the similar triangle of triangle A, B, C, and triangle ADE. ADE are the similar triangle. Similar triangle. The theory of the similar triangle is DE divided by BC is equals to height of the triangle h divided by capital H. What is the value of BC? BC is equals to small b, and the value of DE is equals to z. So this is the z divided by b is equals to h divided by h. So here we can find out the value of z. The z equals to b into h divided by capital H, and put the value of the z in here. So delta I equals to z value of the, put the value of the z equals to b into h divided by h into h this is the dh, sorry, I am very sorry, this is the dh and this is the dh, the area of the elementary z into dh, and the perpendicular distance square h minus h square, h minus h whole square, perpendicular distance square, and the value of the z equals to b into h divided by h. This is the value of the, this is the dh, and h minus h whole square. So b into h divided by h into h minus h is h whole square into dh. if I break it, a minus b whole square, a square minus 2ab minus b plus b square. Now break it, 2a minus b whole square, b into h divided by h into h square minus 2h into h plus h square into dh. Now calculate the moment of inertia, total moment of inertia about what? About base. Find a calculate the moment of inertia about base. So I equals to integrate it, integrate what? 0 from base to apex, 0 to h. We cannot find, we can also find out the cg, find out the moment of inertia about cg, but we don't know, we also know what is the value of here. We subtract the h by 3. Now let me consider, let me find out the value of moment of inertia about base, 0 to h. After calculate the moment of inertia about base, then we can find out, also we can find out the moment of inertia about cg. Let me find out the moment of inertia about base of the triangle. The value will be h2, the value of the limit will be 0 to h. So b into h divided by h into h square minus 2h into h plus small h square into dh. In the next, if I common it from b is the common, b and h is the common factor, we can integrate only small h with respect to small h, integrate with respect to small h. So we can common b and h. Let me common I equals to b by h integration 0 to h and h into h square minus 2h small h plus h small h square, h square minus 2 capital H small h plus h square into dh. Multiplying it, b by h integration 0 to h square into h minus 2h into small h square plus small h cube into dh. b by h integration, integrate it, h square, h integration of h is h square divided by 2 minus 2 into h square is integrate h cube divided by 3 plus into h to the power 4 divided by 4, value 0 to h, sorry 0 to capital H. Put the value of limit, so b by h into h to the power 4 divided by 2 plus 2h into h cube, 2h to the power 4 divided by 3 plus, sorry this is minus h to the power 4 divided by 4. If I put the value of 0, then totally will be 0. So here we can find out, we can simplify b by h into LCM 12, this is 6 h to the power 4 minus 4 into 2 8 h to the power 4, this is plus 3 h to the power 4. So this will be b into h to the power 4 divided by 12 h. 1 h is cancelled, so b h cube divided by 12. This is the moment of inertia about base of the triangle. This is the moment of inertia about base of the triangle is b h cube divided by 12. Now find out the moment of inertia about CG. We need to find out the moment of inertia about CG. What will be the moment of inertia about the CG? Here we can apply the parallel axis theorem. What is the parallel axis theorem? Parallel axis theorem is moment of inertia of any plane parallel to CG, say base, is equals to moment of inertia. We know the formula moment of inertia about parallel to the CG is moment of inertia about CG plus a square a into h square. This we know from parallel axis theorem. Now we can find out this is the moment of inertia of rectangle triangular about base. This is the moment of inertia. Let me consider this is the moment of inertia about CG of the triangle. Now from here we can find out the moment of inertia about CG of the triangle is equals to moment of inertia of the base minus a into h square. What is the value of the h? H is the CG distance of the triangle from the base is h by 3. From the base is h by 3. Now h equals to, here h equals to h by 3. Here h equals to h by 3. The value of the moment of inertia about CG is equals to moment of inertia about base is equals to bh divided by 12 minus area of the triangle. What is the area of the triangle? Half into base into height. Half into base into height into h equals to h by 3 whole square. So here we can simplify the total value of the moment of inertia about CG will be, you can also simplify it, bh divided by 36. This is the value of moment of inertia about CG of the rectangular triangular section.